It tests basic range-bound, non-equi-join mechanics, weighted mathematical aggregation, and logical query design. Understanding the difference between a simple average and a weighted volume average is a key analytics engineering competency. In data warehousing, prices aren't static attributes. They live in temporal tables with validity intervals. Consider this prices table, which details changing prices for each product over time, and this units sold table, which tracks transactional sales. Our goal is to calculate the average selling price for each product. It sounds like a basic lookup, but calculating a true volume-weighted average across active dates is a classic technical screen filter. Let me show you the trap, the cognitive failure, and how to write production-grade range joins. Candidates under interview pressure almost always write this query. They join both tables on the product ID and average the price column directly. There are two major bugs here. First, without date matching, every single transaction joins against every price version, causing a Cartesian fanout that inflates our row counts. Second, standard aggregation functions like AVG calculate a simple arithmetic average of the price tiers, completely ignoring the weight of units sold in each transaction. Let's see this query crash. This error exposes a major cognitive blind spot. Candidates assume SQL aggregation functions magically understand the schema context. They assume AVG price will just work, failing to see that a product selling 10 units at $2 and 1,000 units at $1 does not have an average selling price of $1.50. The true average is weighted by transaction volume. To fix this, we must align transactions to their active price window and compute the ratio manually. Here is the correct solution. First, we join the tables on both product ID and the purchase date falling between the price start and end dates. This prevents row multiplication and correctly matches each sale with its corresponding price tier. Next, instead of using AVG, we calculate the weighted average. We sum the product of units sold and price, then divide that total revenue by the total units sold. This gives us the true, mathematically correct average selling price. In production, data is rarely clean. What if a product has 0 sales? An inner join will drop it entirely. If we use a left join, any product with 0 sales will produce a null sum of units, causing a division by 0 error. To write a bulletproof query, we must use a left join, wrap the denominator in a null if statement to catch zeros, and use coalesce to return a safe fallback of 0 if the result is null. This makes our code production-grade. Remember the range first rule. A price table is not a simple lookup table. It represents a series of time-bounded contracts. Always anchor your transactional facts to their active validity windows, using non-equi-join predicates like between before you perform any aggregation. Once anchored, build your ratios manually using multiplication and division. Internalize this pattern, and you'll easily solve temporal joins, SCD dimension lookups, and volume-weighted aggregations. Let's analyze the AVG price, incorrect trap approach. Time complexity, O of n, log n. Space complexity, O of n, produces Cartesian fanout across all price tiers and averages tier prices instead of revenue-weighted values. Let's analyze the non-equi join plus weighted AVG correct approach. Time complexity, O of n, log n. Space complexity, O of n. Correct production pattern. Range joining on purchase underscore date. Between start underscore date and end underscore date prevents fanout and ensures proper weighting. Let's analyze the CTE pre-filter plus index range scan optimal approach. Time complexity, O of n. Space complexity, O of n. Pre-aggregating units sold to product and date granularity first, then joining with index price ranges to avoid large-scale join multiplication. The interviewer will then ask, what if a product has no sales? Should it be included with an average selling price of 0? Yes, standard interviewer requirement. Use left join from prices to units sold and wrap the calculation. Coalesce, round, sum, units asterisk price, slash, nullif, units, 0, 2, 0. The interviewer will then ask, how would you optimize this query if the prices table contains historical prices for millions of products? Ensure clustered indexes or partitioning keys exist on product_ID, start_date, end_date to prevent full table scans and speed up the between range join. The interviewer will then ask, how does this relate to slowly changing dimensions SCD type 2 joins? The prices table behaves exactly like an SCD type 2 dimension. The join predicate uses the exact same interval matching pattern to associate a point-in-time fact with its active version.